Okay, welcome, Linda and Claudia and Sean and Elizabeth and Stephanie, and hopefully others will come. Let me tell you the plan today. What we're going to do today is really pretty disjoint pieces. First, I'm going to start talking about hypothesis testing, which is a big part of this class. Pretty much the rest of this class is about hypothesis testing. So that's pretty important. We're going to be using some of the stuff we've already talked about, like the normal distribution. But hypothesis testing is all about deciding whether or not you have a result, which is really important to know whether your result is reliable or is it not reliable. So whereas confidence intervals are about estimating and then giving an interval where it might be, hypothesis testing is a way of deciding whether or not you can say you're right. And that's pretty important, especially in research, because a lot of things are yes or no. Either you made it or you didn't make it. So we're going to be talking about hypothesis testing. And then after that, the second half or so, I'll be talking about the exam. So there is an exam. It has to be taken within 8 days. So a week from tomorrow is the last day you're allowed to take it. I recommend taking it Monday, Tuesday, or Wednesday of next week so that you have time to study. And I've written it. It's already it's set up, and I'll show you about ways to study and resources that I put up for you to be able to use. So let's get right to a little bit of hypothesis testing. I want to show you an article. I like Gallup because Gallup gives the data. Okay, lots of articles do what we need to do, but Gallup actually gives you the numbers so we can actually calculate it and check their work. Other articles, you can't check their work. You just have to believe them, which is a little scary. So let me share my desktop. And let me go find it. There we go. Okay. So this is an article by Gallup. And I want to focus first on the title. The title is Fewer Americans Plan to Watch Olympics Than in the Past. So the first thing you might think about is, can they really say that? Do they know for a fact that fewer Americans plan to watch the Olympics than in the past, or watch the Olympics for a lot of you? Okay, Winter Olympics, by the way, in Tahoe are like really important because we win. It's been a while since we didn't get a gold medal in my town, and that's pretty nice. So the question is, are fewer people watching than in the past? Well, do they really know about whether or not fewer people watch the Olympics in the past? What do you think? Right? What do you think? Do they know for sure?
Well, they didn't ask me.
Yeah, they didn't ask you. They didn't ask me either. I bet they didn't ask any of you. I never actually asked and had someone. They did ask me. I've never had anyone say that. They didn't ask most people. You know, there are 300 million Americans or so, right? So over 300 million Americans, and if you go down to the bottom, you'll find out they only asked a little more than 2,000 of them. So they only asked a small group in compared to the population. So they have the right to even say that they know that fewer Americans plan to watch. Does that make sense? So kind of the way things go in whether it's research or whether it is publishing in a news article or whatever you might want to do is it's okay to be wrong sometimes, as long as you're not wrong very often. Does that make sense? That's kind of a good life lesson, right? Tell me, any of you have never been wrong in your life? Good. I didn't think anyone would admit to it if they hadn't. We've all been wrong, right? But the bigger question is, how okay are you with being wrong? So is it okay if you're wrong half the time you talk? Is that okay with you? What do you think? Okay, Claudia says no. All right, what if you're wrong, say, 1/1,000,000th of the time that you talk? Would that be all right? Okay, that's a maybe. I'd hope that you'd be okay with that. Otherwise, you definitely have some insecurities if you think you always have to be right. So the one question you might want to say is, what percentage of the time are you okay being wrong? And we could even look, yeah, so maybe you can all put it in the chat box. What percent of the time are you okay being wrong in terms of making statements? Okay. And everyone might have a different percent. That's possible. Okay. I don't see everyone typing in. So Linda, 10%, Claudia, 5%. Okay. Everybody has, a different amount of time. Gallup, it turns out, is okay being wrong 5% of the time. Okay. So when they do studies, if it wasn't true that fewer Americans plan to watch Olympics in the past, and they did this study, then there's a 5% chance that they would end up misstating the truth. Does that make sense? And that has become standard, actually, in the world, is that for news articles, being wrong 5% of the time is good enough. That's the standard. Any questions on that? Okay, and the interesting thing is, Gallup actually made that decision for the world, I think in the 1930s. And they decided that that was going to be the standard, them and the New York Times, actually. So Gallup and the New York Times worked together, and they decided that that was the amount of time. Okay, so that's the first thing, is now we want to do is say, how do we figure out what the probability is of being right or wrong? Because remember, this is a statistics class, and we look at probability, we have data, and we want to look at those kind of probabilities. So let's take a look at this. So the first thing is I'm going to look at this little chart they've got, and I'm just going to assume, which is probably wrong, but I'm going to assume that the 46% in 2014, that's the last Olympics before this one, is solid. That's just the percent. Okay, for today we're going to do that. Next week we're going to learn that you can actually not have to assume that. But for today we're going to make that assumption. We want to find out, do we think that fewer Americans are watching the Olympics now than they were in 2014? Do you see how that question is? Okay, so I'm going to jot down some numbers, which I already have over here, but I haven't written this one down. So we have 0.46 is the kind of what we're testing from. 0.39 is what we got. And we want to say, well, it's clearly less, right? But that's only for the 2,228 people that they surveyed. Is it far enough down that it would be very unlikely, had it really been 46%, that you're going to end up with 39% when you do your study? And that's what today is all about, is to see what is it? Is it far enough down to say, well, that would be too unusual to really be 46% and end up getting 39%? Or is that not so unusual to get 39% if it had been 46%? And if it's too unusual, then we'll be able to write the article, or Gallup will be able to write the article. If it's not very unusual, Gallup can't write the article. Okay? It doesn't mean that it isn't lower. It just means that they don't know that it's lower. They're not confident enough that it's lower. They don't have enough evidence, is what we're going to say. Any questions so far? So that's the whole point of hypothesis testing. So now I'm going to get into the nitty-gritty. We'll get into the math of it, a little bit of math, not all of it, of course, because we never get into all the math. Okay, so now let me share my desktop with Paint so I can start writing stuff out. New share, Paint. Okay, so the first thing you do is we need to write down what's called the null and alternative hypotheses. And you have seen these before. Some of you, it might have been a very long time ago. but you get it in 8th grade. Okay, some of you might be laughing at how long ago it was, but you get it in 8th grade, and it's called the scientific method. You may have heard of that even if you don't remember your 8th grade science. But you get that in 8th grade and you get in science classes. It's called the scientific method. And the scientific method goes as follows. The first thing you do is you state your hypothesis. You decide what you think might be true. And you decide what you think that you're showing it isn't true. So we're going to write down what we're going to call the null hypothesis, which I'm going to write as the British got to it first, so we don't say H0, we say H naught, because the British use the word not. So sorry if you're not British, but they got to it. Everything else seems to be American. So H naught is, in this case, it's the population proportion, which we use P for population proportion letter. Notice it's a proportion, not a mean, because the survey question is, did you watch the Olympics? Does that make sense? And the answer is yes, I watched it, or no, I didn't watch it. It's not a number. Any questions on that? And what we're going to do is we're going to write down H naught as a status quo. So we're going to say if there is no change, then P should be what it was last time the Olympics happened, which was 46% or 0.46. Any questions so far? Okay, and then, again, if you remember your 8th grade science, which I don't expect you all to remember, you write down what's called the alternative hypothesis. And that's H1. Usually use subscripts, but I'm typing so it doesn't do subscripts. But H1, and that is that P, in this case, we're trying to show, Gallup thinks that it's less. Does that make sense? Gallup thinks that the proportion is less this time around. So we're going to use a less than sign. 0.46. Okay, the first one is called the null hypothesis. And the second one is called the alternative hypothesis. So just a note, I like to kind of get you a good feel about projects while we're going. Last week I told you about half of the project, and that was confidence intervals. This week, we're doing the other half, and that is hypothesis testing. So the very first thing you do after getting a partner, by the way, that's always number one, is decide on what your null and alternative hypotheses are going to be. Don't decide on your survey question. Decide on what you think is true. So you're going to think something's different than something else. And what you're going to be doing, what we're going to do next week, so I'm going to give you a precursor of what's going on, is next week we're going to compare two different population proportions and means. So your hypothesis is going to be for two different population means. So it might be the mean for men is less than the mean for women in something. Or it might be that a person spends less time doing this than they spend doing this. Those are the two types of hypothesis tests we'll be doing next week. And the project is actually about next week. But this is getting you going. This week gets you set up for that. Any questions? Any questions? Okay, so there's an order at which you do things. It's really important that you do the order correctly. This is going to be important on your project especially. So then the first thing you do again is you decide on your hypotheses. H naught was P equals 0.46. H1 was P is less than 0.46. The next thing you do is you decide what the ramifications are of what's called a type 1 error and a type 2 error. So let me write those out. So a type 1 error means the following. It means that you end up concluding that the alternative hypothesis is correct when it isn't. Okay, so in this case, what that means is that Gallup has decided that fewer people are watching the Olympics. And they tell the world that. We saw that in the article, right? But they're wrong. It turns out that just as many people watched the Olympics this year as last time, or maybe even more people watched. Does that make sense? So one of the things you want to ask is, how horrible is that if that occurs? So for Gallup, what it means is that people are going to trust them less. Do you see that? I don't think anyone's going to die. Do you agree? Right? If they hear that fewer people are watching the Olympics this time around and Gallup wasn't right, it's not going to kill anyone. Do you agree? So it's not that big a deal. It's more of a newsy thing. It's more for the reputation. And when it's that kind of thing, you typically use 5% for what's called that level of significance. That was what I asked you. What percent of the time are you okay being wrong? And in that case, you're going to use 5%. Okay, so this is a particular one where it's a news article. So let me give you another type of example where that might be a different issue. Let's suppose that you are, instead of talking about news, let's suppose you're talking about medicine. Okay, a whole different issue. And what you want to do is you want to maybe give a new drug or surgery, let's go surgery, to people to try and fix something. Okay, by the way, I'm not a doctor or nurse or anything like that. But let's suppose that there's a new procedure out there and they think that procedure is going to say, do better than just resting at home. And that procedure involves full surgery. It's very expensive. And of course, there are complications that could happen because it's surgery. So in that case, a type 1 error, and maybe it might make you, I don't know, if somebody has knee problems, for example, because that's a typical thing in Tahoe. Okay, and now we have this new surgery that they're going to recommend for anyone who has a small knee injury. Well, the problem is if you have a type 1 error, then what you're going to end up doing is you're going to be giving surgery to all these people, and the surgery didn't help at all. So in that case, do you think 5% is a good level of significance, a good percent? What do you think? Yeah, in that case, you probably wouldn't want to use a 5%. You'd probably use more like a 1%, because you really want to be sure that you're right, because if you're wrong, a lot of people get hurt. Does that make sense? So what you want to do is you want to look at the ramifications of the type 1 error. And the type 1 error probability is that 5% or whatever percent you decided on. Does that make sense to everybody? Okay, so in medicine, often you're going to do less than 5%. Okay. On the other hand, sometimes, like in the Forest Service, I've done some consulting for the Forest Service up here, and they wanted me to do 10%. And one of the things, and I don't know if you agree with me, but when you are working for someone and they tell you something, you go by the boss is always right rule. And if they tell you they want a 10% level of significance, then use the 10%. Okay, that's just something, is you use whatever the agency tells you you need to do. You let them know what it means, but then when they say we want 10%, you do 10%. So in news, you always use 5%. In medicine, it depends. Okay, in the Forest Service, they usually use 10%. Okay, then there's the type 2 error. And the type 2 error is kind of the opposite, but not quite. So the type 2 error means that you end up not being able to make a conclusion. When the alternative hypothesis was actually correct. And that's bad also. Okay, so for example, I'll give you a different example. Well, let's do this one first. In this case, what it means is that Gallup did the study. They might have gotten this 39% for the percentage of Americans or percentage of their sample who is watching, planning on watching the Olympics. And they say, well, that's not really far enough from 46%. So we really can't say that fewer people are watching the Olympics. So what ends up happening is they don't publish it. Okay, they don't publish it. They don't say that it's the same, because that's not what they got. They just say nothing. So it means that you can't be able to make a conclusion. You don't publish your results, and actually you were right in the first place. So it was true that fewer are watching the Olympics, but they weren't able to say it. Okay, so that's bad for them in a different way. So if that happens, that means that they were right in the first place, but they weren't able to have an article at all. You see, different kind of damage. Doesn't hurt their reputation, but it means that they have less to publish, and that's bad too. Right? A news station isn't very good if they have nothing to say. Okay, so that's called a type 2 error. The probability of that is too complicated for this class. So we're not going to go into the probability, but it does weigh into a few things. One is that if the type 1 error and the type 2 error are somewhat even, you use 5%. If the type 1 error is a lot worse than the type 2 error, then you typically use 1%. If the type 2 error is a bad one, and the type 1 error is not that bad, then you typically use 10% for the level of significance, that percent that I asked you at the beginning. Any questions so far? Any questions? Another good example I like to use is the court of law. Okay, so it was a bunch of years ago. I actually missed 2 weeks of class. You can imagine, not online because I do it at night, but of my day classes, I had to miss 2 weeks because I was on a jury. Okay, and any of you ever been on a jury before? Any jurists in this room? Okay, so Claudia, you understand, right? You have to make a decision at the end, right? And it's not guilty or not guilty, actually. Do you realize that? I don't know if you realize that when you're making a decision. It's, I have evidence to show the person's guilty, or I don't have evidence to show the person's guilty. Isn't that how it works? Hopefully the judge explained that to you. I actually explained to everyone. I was the foreman too. When they heard I was a statistics professor, they voted me the foreman. Okay, so we had to decide, yeah, beyond reasonable doubt. And the interesting thing is that is so statistically important. Reasonable doubt is like that 5%. Do you see? So if there's a 5% chance, if there's less than a 5% chance that the evidence is not true, that they're guilty, then you don't have evidence to show they're guilty. Do you see how that works? Okay, so a type 1 error means that you had the evidence, or you said you had the evidence to show they're guilty, and they're not. That's a bad error, isn't it? And a type 2 error means that you didn't have any evidence, and you actually don't find them guilty because it wasn't beyond a reasonable doubt. Do you see that? So, by the way, what do you think is worse in the court of law, a type 1 error or a type 2 error? And there's your opinion, and then there's what you are supposed to go by. Okay? Okay, so Claudia, you say 2. What about the rest of you? So in a court of law, what's worse? Nobody wants to commit? You could say it too if you don't have a typewriter. I mean, if you don't have a keyboard.
Well, if he's guilty and you let him go, is that a type 1?
Guilty and you let him go is type 2, because that means you didn't have evidence, but he was really guilty. Do you see that?
But I'd hate to put an innocent man away too.
So in our court of law, A type 1 error is worse. Putting an innocent man or woman, by the way, in jail is worse than letting someone go free who's guilty. Okay, that's in our society. Whether you agree or not, that's how our court system works. There's other countries where it's not true. They just throw anyone in jail even if they're not sure. Does that make sense? In our society, if you don't have real strong evidence, you don't put them in jail. Okay, and in fact, in the particular case that I was in, there was a chance that she might have done it, and we found her not guilty, which means that we didn't think she was not guilty. We just didn't see the evidence for it. Do you see? For guilt, which is different than thinking she's guilty or thinking she's not guilty. There wasn't evidence to show she was guilty. And there was a decent chance that we committed a type 2 error, but the evidence wasn't there, and you have to go by the evidence. Does that make sense? You don't go by a heart, you go by what testimony you saw, which is very different. Okay, so just wanted to talk to you about these errors because they're really important. Okay, so once you've decided your level of significance, the first thing is, let me give you the letter we use. And the letter you use for level of significance, I'm going to have to write this in a pen because it's not something you can type. And you might have seen that letter before. Anyone know what that's called? By the way, it's not called fish.
Alpha.
Yeah, it's alpha. It's the first letter of the Greek alphabet, and in fact, it's why we call it the alphabet. Okay? Because it's Latin for alpha is alpha, and Latin for beta is bet, it turns out. Bet is actually Hebrew. So I'm not sure where that came from, but something like that. So alpha is a Greek letter, and in this case, what we're going to use 0.05 because we're doing news. Any questions on that? Okay, if it's not given, then you pretty much assume it's 0.05 and you look to see what you get. Okay, the next thing we do, I'm going to write down what I call a cast of characters, and that is we had N was 2228.
I have a question.
Mm-hmm.
Why wouldn't it be given?
In the real world, no one tells you. If you want to find something out, no one is going to say you need to use 0.05. You know what I mean?
So if you don't have that, and assume you're doing a project, you always want to do a 5% margin of error.
Okay, so this is what I was saying about type 1 and type 2 error. This is kind of important, is that if you're doing your project, because I'm not going to give you alpha, you're going to judge the type 1 and type 2 error. If they're pretty much just as harmful, then 0.05 is the right thing to do.
What would determine just harmful?
You look at it. You look at who gets hurt. So in this case, it's about equal. So in this case, type 1 error was when they ended up publishing that fewer people are watching the Olympics and they were wrong. That's bad, right?
Right.
A type 2 error means that they did all this research and they can't publish anything, but they were actually right in the first place, and had they published it, they would have been right. That's pretty bad too, right?
Yeah.
But neither is devastating. No one gets killed or anything. There's a balance between the two. If there's a good balance between the two, then you go for 0.05. Whereas if one of them kills someone and the other one just hurts your reputation, then that's important. Does that make sense? You don't do 0.05. So if a type 1 error kills someone, you're going to use like 0.01 or less. You see? If a type 2 error kills someone, you're going to use more like 0.1 or 0.2. Does that make sense?
So when would you ever use a 0.1?
Okay, so an example of a 0.1 is, let's suppose, this was a nice little example that happened in Africa. They did a study, and they wanted to find out if circumcision, you know what that is?
Yeah.
Okay. Will help prevent AIDS. Okay, now Africans don't get circumcised generally. Okay, so they did the study, and when you think about it, a type 1 error means that you have, it's for a man, you're not men, so you may not have that good feeling, but it's going to be horrible. You see, it's going to be really painful, right? To get circumcised and there was no reason as an adult. Okay? So again, I'm not going to get into the graphic details, but you can imagine it wouldn't be so good, right? That's a type 1 error, right? Type 2 error means that you're going to have a much greater number of people getting AIDS,
If you do.
but they could have prevented it by circumcising all men.
Okay.
Do you see that?
Okay.
So what did the Forestry Center have you do? What kind of a thing would give you a 0.01?
They use 0.1.
They use 0.1. Oh.
They use 0.1. They use 10%. So 0.01 is kind of the opposite kind of thing, where a type 1 error is worse. So let's suppose that you want to find out if this new medicine for acne is helpful. Okay, or one I like to look at is type 1 error. Let's suppose that you want to find out whether giving, this is one I gave on a test once, giving people a very extreme electric shock every time they touch a bottle of alcohol is going to help them stop drinking. So type 1 error means that you're really abusing somebody and you're zapping them and destroying their life. Do you see that? Whereas a type 2 error, maybe you can find another way of making them stop alcohol. Do you see that? And that would be where you would probably use a higher level of significance, because you really don't want a type 1 error because you're going to get sued badly.
So you said that the worst error you can make is a type 1 error.
So no, if type 1 is worse, you use a lower alpha. If
Okay.
type 2 is worse, use a higher alpha. If they balance, you use 0.05. Does that make sense?
A little bit.
So you judge the two. So in news, they typically balance.
So type 1 would be a 0.01?
Type 1 typically 0.01. For our class, we'll keep it at 0.01.
And type 2?
Yeah, there are cases where we use less, but for us as elementary statistics, I just want you to learn the ideas instead of the exact stuff. Again, there's some math I'm throwing way under the carpet, by the way.
That's fine.
Okay.
Throw it deep.
What's that?
Get rid of it.
Yeah, but the one bit of math I want to show you, because this is important. Any guess on what I'm about to draw?
Bell.
Yeah. Right. That is the picture of the class. Okay. So if we have the alternative hypothesis P is less than 0.6, the first thing is 0.6. We're going to hypothesize is the proportion or the mean for the central limit theorem. So 0.46. And then what we're going to do is we're going to look at this less than sign. That kind of indicates left side, doesn't it? And the less than sign tells you that we're to the left of some value. And if we're going to use 0.05, then that means that this area here is 0.05. And that's going to give you a demarcation point. Right here, I'm just going to call that X, so we don't know what it is. We can find it pretty easily. But that's going to be X. And what we're going to do is we're going to say if the proportion that we got from our sample is over here, then we're going to say we have evidence, because there's a very small chance we're wrong. Do you see that? Less than 5%. On the other hand, if what we got is here, then we're going to say we don't know if we're right or wrong, because there's a higher than 5% chance. Do you see that? It's not that unlikely to be there. Okay? The area to the left of what we got whether it be this spot here or this spot down to the far left, the area to the left of that is called the p-value. And what you're going to do is you're going to say, is that area small or is that area large compared to 0.05? And if the area is small, then you're going to say, yes, we have evidence. If the area is large, then you're going to say, we don't have evidence. Okay, and that's really what's going on. And there's a normal curve here. Because of the central limit theorem, we know we have a normal curve. And notice that if you take NP, if you take 46% of 2,228, I hope you don't need a calculator to know that's bigger than 5. And if you take 54%, that's 1 minus 46% of 2,228. Hopefully you don't need a calculator to know that's also bigger than 5. So if they're both bigger than 5, then we could say the distribution is approximately normal. Do you remember that? And we can go ahead and do the calculation. So now I'm going to show you the calculation quickly. I'm going to go and reshare and go to the calculator. Okay, so I'm going to go now to stat. I'm going to go to tests. As I mentioned, the whole rest of the class is all about this test button. Okay, we had it last week, we're having it this week, we'll have it next week, the week after that, week after that. So that's what we're doing now. This particular one is going to be a one prop z test. Now we have seen the one prop z int before. This is a one prop z test because we have a hypothesis test, not a confidence interval. One means there was one survey question asked with one population, and that is, are you watching the Olympics? Prop means that we have proportions. It's a yes, no question. Are you watching Olympics? Yes, I am, or no, I'm not. Z meant that we had a large enough sample size so we can use the normal distribution. And test means that we can, we're doing a hypothesis test with H naught and H1. So I'm going to hit enter there. It's going to ask us some things. It's going to ask us for P sub 0 or P naught, and that is the hypothesis test when we had H naught mu equals 0.47. So that's going to be 0.47. And then it's going to have X. Now in this case, Gallup didn't give us X. Gallup said there was a sample size of 2,228, and 39% said yes. So I did on my own calculator, 39% of 2,228 is 869. And that was a number of people who said yes to the survey question. Then our sample size is N, and that's 2228. And then you have three choices, not equal to, less than, or greater than. And that has to do with what the hypothesis is. In this case, the hypothesis is that we think that fewer people are watching the Olympics. So that means we're going to have a less than. If the hypothesis was that it is different than before, then we'd have a not equal to. If the hypothesis was that more people watch the Olympics, then you'd have a greater than. Does that make sense? So I hit enter there. The color, I don't know why they tell you about color. I don't care. And then we're going to go to calculate and hit enter. Okay, so it gives us some important things. Notice, by the way, that P equals 0. What does that tell you? That means that it is so far to the left that that area is beyond what the calculator could even calculate. And it's just 0. It's 0 to like 7 decimal places or so. Any questions on that? Okay.
Why is that important?
Because that means you're like really, really, really satisfied and confident. You have extremely strong evidence. So again, we talked about the issues of a type 1 and type 2 error. So at this point, we really know it's true because it's so unlikely you're willing to stake your life on it. Does that make sense? There's
What
like,
if you get a number?
what's that?
What if you get a number?
Okay, so let's suppose you got p equals 0.03. So that's a really good question because I want to talk about the different choices that could happen. We're going to do the what ifs because that's important. If you got p equals 0.03, that's less than 0.05, and that's enough evidence. Do you see that? You don't say it is extremely strong evidence, but you just say we have evidence, or statistically significant evidence is the word. If you have, let's say, 0.07, then that's bigger than 0.05. Does that make sense? And then you're not there. You're devastated because you're so close. Do you see that? You got 7% when you wanted to get less than 5%. So you say you don't have evidence. And then you say, but I still think I might be right. And the only thing you can do at that point is a much bigger sample size. You can't just keep doing sample sizes of the same until you get lucky, because each time you have a probability of a type 1 error, if you do it enough time, you'll eventually get that type 1 error. So you have to like tenfold your sample size, and you're crying because that's a lot of work. Does that make sense? If you get something like 0.8, then you say it's time to give up. I was probably wrong in the first place. Does that make sense? Because you're not even close, right? If there's an 80% chance that you're wrong, that's not okay. Does that make sense? Okay, so there's different values of P and really different feelings for each of them. This is the best you could ever get is 0, as in the one that's going to make you feel the best. Okay, if your goal is to publish, by the way. Sometimes you can now publish, but you just found out that you have a disaster. But now you could publish as a disaster. Do you see that? Okay, is that clear? Okay. P hat, that was the 0.39, and then N was the sample size. All right, any questions so far? Okay, now let me go back to the paint. And let me let you know. Please share the application. Oops. Share screen. There we go. Okay, so now let's talk about the conclusion. So this is a conclusion, and what we can say is there is, in this case, strong, because P was so very small, statistically significant evidence. Okay, notice that you didn't even need an alpha. P is so small, it's smaller than any alpha. Sometimes you need an alpha, though, to conclude that and now what we're going to do what Gallup did. We can actually talk about the population of all Americans. We're not going to talk about our sample anymore. That the proportion of all Americans and I capitalized all, because if you don't write down all on the test next week for this conclusion, and also for confidence intervals, then I will take off points. Otherwise, you could be referring to the sample of Americans. Does that make sense that you took? But it's actually all Americans. If you have a mean, then I want to see the word population mean. But for proportion, the proportion of all Americans is probably good. You can say the population proportion of Americans is fine too. Of all Americans who will watch the Olympics, this time around is smaller than the last Olympics. Any questions on that?
So did you accept, or did you just fail to reject?
No, I strong statistically significant evidence is accept as you could ever get, right? That's like accepting and bragging about it.
Okay.
Right? Does that make sense? Had the p-value been, say, 0.08, then you would say there is insignificant evidence, statistically insignificant evidence, to conclude that the proportion of all Americans who have watched the Olympics this time around is smaller than the last Olympics. Do you see? 2 little letters changes the entire thing. So having statistically significant evidence is very different than statistically insignificant evidence. Any questions on that? So notice that when you say there is statistically insignificant evidence, all you're saying is a very fancy way of saying I know nothing. I did this research and I still don't know anything. Whereas if you have strong statistically significant evidence, then you say I do now know. Do you see the difference? Any questions at all so far on this? This is really important. Okay, just a note. Let's suppose, I'm going to give you a different P just to make it a little easier. I want to do real life, and real life doesn't always have it. Let's suppose P instead was, say, 0.02. Then you still have significant evidence, right? But what does that p-value mean? What that means is that had it been the same, okay, so if the proportion of, let me write population proportion, of all Americans. By the way, that's redundant, but sometimes it's good to like have redundancies. Got population and all, those redundant words. So you gotta have at least one of those. I'm gonna put both for now. Of all Americans who will watch the Olympics. This time around is 0.46, same as last time. And if another study of 228 Americans was done, okay, and let me go, instead of study, it's sample, was done. Sample was surveyed or were surveyed? I think was. Yeah, were surveyed. This isn't an English class. Then there would be a, let's say it was 0.02, 2% chance that we would end up getting at least, oh, sorry, not at least, it's at most, because it's a less than, 869 of them having watched the Olympics, or planning of them watching the Olympics. Any questions on that? There's no short way to do this. So if you think you can do a short way, think again. Got it? So just a note, the conclusion is this first paragraph. If I say state the conclusion, I don't want the second paragraph. The second paragraph is to interpret the p-value. What does the p-value represent? Does that make sense? Okay, you're going to be asked next week, so be ready for it.
So what if you accidentally give you both?
Well, there's going to be an A, B, and a C. Put it in the right place.
Okay.
Yeah. Yeah. So this test is going to have lots of parts, and I'm going to show you in a little bit. I should have mentioned we're going to go a little bit over 7 today because I want to talk about the test, unless you guys don't want me to talk about the test. But I can't imagine you not wanting me to talk about the test. So there's a lot to talk about today. I thought about doing 2 days, but I try to do this 1 day a week. I think that works better. I'm not sure, but it seems like it. I used to do 2 days a week, and attendance wasn't very good.
Maybe you should do a webinar for the people that struggle with homework.
Well, I'm always happy to help you online. That's office hours. So if you ever want me to help you, I'll help you during office hours.
Okay.
Okay, that's not a webinar. That's just working on homework. Does that make sense?
Yep.
Yeah. So there's different things. So I do have office hours. I'll have them tomorrow. The only thing is we take turns because I have my face-to-face students come to my office too. So it's different. It's not recorded or anything like that. Okay, so I want to do one more thing, and that is talk about what it means to have a level of significance of 5%. And what that is, again, is a probability of a type 1 error before you start. At this point, by the way, at this point, after we've already done the conclusion, what is the probability of a type 2 error? Anyone know? The hint is it's really easy.
I want to say 0.
It's 0. Good. And why is it 0?
Because there is no statistically significant evidence.
Right. We found statistically significant evidence. So there is no chance that we weren't able to make a conclusion. We made a conclusion. Does that make sense? It's a little bit like, what is the probability that it rained yesterday here? 0. It didn't rain here. It snowed. Does that make sense? Once you know what happened, then that changes everything. Does that make sense? Okay. But before you start, it could happen. And there still is a probability of a type 1 error, but it's really low because our p-value is so small. But before you start, then we can talk about the level of significance. You usually want to talk about level of significance before you begin. So that is saying the following. The first thing, I wonder if I can copy and paste this. No, I can't. Okay. So you start exactly the same, and that could be a little confusing. And that is if the population proportion of all Americans who will watch the Olympics this time around is 0.46, and if another sample of 228 Americans were surveyed, then there would be a 5% chance. So now we're talking level of significance, that we would end up falsely concluding that the population proportion of all Americans who will watch the Olympics this time around is less than 0.46. Any questions on that? Notice it starts the same as the p-value interpretation, but it's very different. Okay, first thing, notice in the p-value interpretation, it's the probability of a sample proportion being something. For everything else, it's all about the population proportion. Any questions on that? Any questions? Okay, I want to mention a couple things before I start talking about the test. One is that I decided to spend a lot of time on one example. I think that's important. If I rush through a bunch of examples and don't go into detail, I think that's worse. But I didn't do a population mean or a question about the mean. I only did a question about the proportion. So be careful in your wording. If the survey question is quantitative, okay, then The word proportion should not be there. Is that clear? So don't just memorize the wording on this and say all hypothesis tests have this wording. Okay, it works well for proportions, but for means, you don't have population proportion. What would you have? Into this really easy. Any thoughts? So if it's about means, you wouldn't say it's the population proportion of all Americans. What would you say? Yeah, you would say the population mean. And you usually don't have the word all, because all is confusing. So if you talk about means, you don't go of all Americans, you say the population mean, and that does it for you. Any questions on that? So that's really important, is don't get confused. If you're looking at sample sizes, like here I looked at noticing that NP and NQ are greater than 5. Remember that? Because it was a yes-no question. If it's a means question, if it's quantitative, then the number 5 is not relevant. What number to use then? Do you remember? Yeah, 30. Greater than 30. Don't get them mixed up. It's probably the #1 mistake I see on the midterm, is getting quantitative versus yes-no question mixed up, because the whole thing will fall apart on you. So think about, what is the survey question? What are you going to ask that American on the phone when you are conducting the survey? In this case, it is, will you be watching the Olympics? Does that make sense? In other cases, it might be quantitative. That's how you start the entire process. Any questions on this? Any questions? Okay, so I'm not going to do an example of means, because we've got a whole hour already, and I still need to get to the test. And I don't want to totally burn you out. I want to talk about the test, and but before I do that, are there any questions at all about hypothesis testing? Hopefully you see the order at which you do things. The order is important, by the way. Okay, there's no flexibility. Okay, there's definitely the order. Is you state the null and alternative hypotheses, you think about the type 1 and type 2 error, you come up with your level of significance, put in your calculator, and then write your conclusion. That order is necessary. If you actually start out with your data and then try and find conclusions based on the data without having a hypothesis, that's not statistics. Okay, that actually is really important, and it's used in some very important applications that's probably beyond all of you guys. It's done in what's called data mining. Have you heard of that? Or big data? It's all part of the artificial intelligence thing. So I'm not going to get into that. It's really intense, but really important. And that's when you do things in the opposite order. But if you're doing for publications, this is the order you do it in. So they're different. Okay, so let me, I'm going to give you the secret word now, because I figure everybody at this point will probably stay online even after I give a secret word, because I'm about to talk about the midterm. So the secret word for today is statistically. Statistically. So notice that I, in the conclusion, there was statistically significant evidence. So that's an important word. I always like to make the secret word important, but you probably wouldn't guess it if you didn't watch the webinar. Sound about right this time? Probably wouldn't have been in your top 5. So any questions at all? Any questions at all about hypothesis testing before I move to the test? Okay, I'm about to erase all this, because I want to put something else in, and that is the instructions. So now let me get to the instructions. That would be here. There it is, just a minute. Uh-oh. Let's try this one more time. Copy. And I'm getting the spinning wheel of death. Oh, come on. Well, maybe it's not going to let me do it. So let me try it another way. Uh-oh. It's being mean. Come on, there's got to be a way. My computer's being mean. Copy. Give it some time. Try the clipboard. All right, well, I apologize, but it is not copying and pasting. It's giving me the wheel of death. You've seen that before, right? So I think I'm just going to read it to you because I can't put it up here. I wonder if I can copy and paste it somewhere else and then put it up there. That's another way of doing it. Let's try this. One more try. Apologize for the delay, but computers do weird things. Okay, gotta improvise. Okay, so here are the rules, and I can see you squinting, so let's see if I can make it bigger. Does that help? Okay, so dear, and that'll have your name. I'm sorry, that won't have your name. That'll have your proctor's name. And then these X's are your name. I didn't want to, embarrass anybody, so I did this. We'll be taking the statistics midterm with you. I have attached the exam. Here are the rules for the exam. So this literally is what's going to be sent to your proctor, except the X's, of course, are going to have names. Number one, please check the student's ID to verify the student is indeed whatever that name is. So just to note, you must bring your ID, whether it's your student ID or your driver's license, passport, some photo ID that will show that you are who you are. Okay? So that is something you must bring to the exam. All right, the student may bring pencils, pens, any calculator, but not a smartphone or a computer with a calculator on it. A 3-inch by 5-inch note card with writing on both sides and blank scratch paper. So that's what you're allowed to bring to the test. Any questions so far? The student may not bring a cell phone. Okay? Notes other than what the student has put on the 3x5 note card or any book. So again, I'm letting you know what to bring. So if you bring a cell phone, you have to hand it to the proctor. That's what that means. So you can't use a cell phone on the test. Okay? The student has 2 hours to complete the midterm. Make sure you get yourself 2 hours, okay? Don't try and do it in an hour because it's a long midterm. After the student has completed the midterm, this is probably not very important to you, either scan it or email it to me and fax it to me that's our fax number at the college. If you fax it, please, I'm just going to go through this fast. Put my name on it. Okay, that's more for the proctor than for you. You don't have to care about that. Okay, so And then it says, if you have any troubles opening the exam or any other questions about the proctoring, please let me know. Thanks, Larry. So that's what gets sent to your proctor. Okay, of course, if you're taking it at LTCC, they have a proctor form I fill out, but it's basically the same thing as this. But if you're taking it anywhere else, I send them this email, and I attach your midterm in a Word document form. Any questions about the rules first of the midterm? It's pretty straightforward. I don't think there's anything too unreasonable. Okay, and if you have a disability, then your accommodations will be met. That's just a note. So, for example, I have a student that can't write because she's got some issues. So what I told the proctor is that if the amount of stuff that she has on her big piece of paper can be put on an index card, that's okay, because she had a disability. Okay, so those are the kind of things that could happen. So if you have a disability, I'll make sure it's met. But again, if you don't, then these are the rules. Okay, any questions at all so far?
I have a question.
Yeah.
So if we are taking the test at LTCC, did you still want us to send you the names and emails of our proctor?
No, I don't need the name, but you need to write LTCC.
Okay.
Because I have to give it to them. I have to give them the test and put your name on it. And if I don't know you're taking it LTCC, I'm not going to give it to them. Does that make sense?
Yeah.
I just would be confused why you didn't give it to me.
The proctor said they were going to email you at LTCC.
Yeah, you can email me. Yeah, email me.
The proctor at LTCC said they were going to email you.
Oh, they said that?
Yes.
Okay, maybe
that's what they told me.
But I've never had them email me, so I would recommend emailing me also, just in case.
Okay.
So if they're going to email me, that's new, and I've been doing this for a lot of years. So just it's not hard to send me an email, right?
No.
Just send me an email. That's the easiest, and then we'll make sure it happens. I don't want to say I don't trust the proctors, but I'm just telling you in the past they didn't email me. Does that make sense? So
Got it.
You're better off emailing me yourself. Okay. And in fact, what I usually do, if you're taking it off campus, I recommend you contacting the proctor after I send you the note that's saying I sent it, just to make sure that they're ready. Does that make sense? Okay. One more thing I recommend you bringing is spare batteries. Because it would be awful if your batteries died in the middle of the test. Don't you agree? And the proctor will let you bring batteries, by the way. I don't think anyone could ever cheat with batteries. Any questions on that? Okay, so now I'm going to change what I'm sharing. And I need to do a couple things. And let me go to that one. Okay, so hopefully you can see the Canvas site. I'll make it a little bigger. Okay, so if you go to modules, and if you go to week 8 is when you take the test, so that's where I put it. Okay, you're not gonna see this. I didn't put that was last year's test, but what you're gonna see, I would start right here at Sketch of Midterm. All right, so what I did actually, this is a sketch from last time, but what I did is I started with this. This is the actual midterm, which I'm only going to show you the back of, so you can't see anything. But this is the actual midterm. The way I write the midterm is I started with the sketch and then filled it in. Does that make sense? So this will tell you what's on the midterm, the ideas of it. It doesn't give every detail, but it gives you a lot of them. So let me just go through these and make sure you're ready. Okay, so problem 1. For each part, be sure to write down the sampling distribution, put in your normal curve diagram, answer the question, and determine whether the normality assumption was needed. A scenario will be given, and then there will be a part A and a part B. So this is 2 different chapters. What chapters could this come from? So what chapters could this come from? Still wait, not 4 and 5 actually. We didn't have the word normal in 4 and 5. Right? 4 and 5 had uniform. 4 was a probability distribution functions. Yeah, this is 6 and 7. This is chapter 6 and 7. So let you know, where are these coming from? This is chapter 6 and 7, and it's a big part of the test. And the only thing, I think the points may not be true. I think I might have made them all the same number, except for true falses. So, well, maybe not. No, they are right. Okay. Okay. So make sure you do that. I tried something new this time around. Is I actually, since I asked you to do 4 things, I write down the 4 things down, and you have to fill in for each of them. Okay. Question number 2 is I give you a scenario, and you have to talk about a type 1 error and a type 2 error first, and that's what we did today, right? So make sure you take this week seriously. Okay, and then you have to conduct the hypothesis test. Be sure to state the null and alternative hypothesis, the p-value, the test you're using the calculator, then state the conclusion using a complete sentence in the context of the study. By the way, what are the first 2 words of part 3 of problem 2? Which I actually call part C in the real test. What are the first 2 words that you should be writing for the state your conclusion using a complete sentence, in that complete sentence? This will help you get ready. Okay, I don't see y'all jumping in. That's one of the words in there. That's actually, that is the 3rd word. The first 2 are there is. And then statistically. And it may or may not be significant. It could be insignificant. Remember that. Okay. Problem 3. Please circle the following true or false. And there are 8 of them. Okay. That's one of those there's no word to show. If you don't know, don't leave it blank, because then you're just being silly. Go for the 50%. This is a probability and statistics class. You should understand that a 50% chance is better than a 0% chance, right? So don't even think about leaving any of those blank. So make sure you circle either true or false. Okay. Problem 4 is a uniform distribution question. So there's going to be 3 parts. One of the parts is going to need material from chapter, let's see, is that right? Yeah, chapter 4. Okay, and I like to mix chapters sometimes, so be ready, but I'm warning you now that you're going to need material from chapter 4. So this is a mix of chapter 4 and chapter 5. Okay, it's a little more chapter 5 than it is chapter 4, but you definitely need both. Any questions on that? All right, what picture should you have for problem 4? In one word. Yeah, rectangle. A rectangle. Not a normal curve. We didn't even know what a normal curve was hardly in chapters 4 and 5, right? So just be ready. Okay, problem number 5. That's going to be a question that involves statistics. So mean, median, mode, standard deviation, z-score, interquartile range, all those different statistics. Remember those statistics? I'm not going to tell you which one or which ones, because I want you to know them all. But it's going to be directly about some statistics. Any questions on that? So that's really from chapter 2. Just to give you chapters. The problem, this test is weighted more in the later chapters, because the later chapters use the new chapters. but there are some old stuff. Okay, problem 6 is a confidence interval question. The only thing is, sorry about my numbering system, it's A, B, C, and D, not 1, 2, 3, and 4. I don't think you're going to be bothered by that, though, right? And the first, there's going to be obviously a little paragraph, some stuff given, and then there's going to be 4 questions. The first is determine the appropriate 95% confidence interval. The second is write a sentence that explains your findings. For question 2, or BLB, what are the first few words? So what's the first maybe 7 or 8 words that you can write for question 2 to explain your findings? You remember? Yeah, with 95, it won't be X. I told you it's 95%. With 95% confidence, it can be concluded that, and then you're going to have stuff. Does that make sense? Okay, what I'm trying to do is not surprise you with this test, but you do have a lot of work to do, a lot of studying, a lot of practicing. So then number 3 is write a sentence or 2 to explain what it means in this context, in the context of the study, to be whatever percent confident. In this case, it's 95% confident. Okay, and then the last, was it necessary to make any assumptions about the underlying distribution of the population? That has to do with sample size and the central limit theorem. Okay, number 7 is another confidence interval question, but in this question you also have to find, you have to do a sample size computation. Remember there were 3 formulas. There was one that was 0.25 times z over e quantity squared. There was one that was p times 1 minus p times z over e squared. And there was another one that was z sigma over e quantity squared. There were 3 formulas depending on what type of problem it is. So I would recommend having those formulas on your note sheet and also knowing how to use them, knowing when to use which. Big problem a lot of people have is not knowing which one to use. And if you try to use the wrong one, it's going to go badly. The other thing is the z you find using inv norm. I want a picture. I want a normal distribution picture if you're going to use inv norm. Okay? So practice it. Don't memorize values of z. I'm purposely making it some weird confidence level so that you're going to have to use an inv norm. Okay? You don't want to memorize every possible confidence interval. It won't be 95% for that particular one. Okay, problem 8. Problem 8 is a hypothesis test question. Okay, notice this has different questions in it. So first, null and alternative hypotheses, test statistic p-value. Second is complete sentence to do the results. And that is, so this is very similar to what I did today, except not type 1 and 2, type 2. That's the other hypothesis test question. Okay. Just a note, don't get confused between mean and proportion. They're different. That's a problem I see a lot of. Okay, problem number 9 is a statistical chart. It's either going to be a histogram, a stem and leaf, or a box plot. And then you're going to have to ask probability questions about them. And you also better show you understand what the standard deviation is and what it means. Okay, and then question number 10. This is the only one I didn't change anything, other than there's more space between for you to write answers. This is the extra credit question. So I tell you there's no extra credit except this. This is the one bit of extra credit for the entire course. It's your one chance. And all you have to do is put anything in it and you get your extra credit. If you leave it blank, you don't. So basically it is to talk about how to improve the class. It's how can I help you guys out. It's what I did right, what I did wrong. And then also a little bit of self-reflection. So what you did right that helped you, and what you could have done better so that you could have done better on this exam or whatever it was in the class. Could have been the project or whatever it is. It doesn't have to be the exam. It could be anything from the class. Okay, and that is what the midterm is going to look like. Obviously, it's not going to be 1 page. I'm going to have lots of space for you to write down answers. So one of the big differences is that there's lots of space in between everything. The other big difference is I actually give you numbers and data that you have to analyze. Did that sketch help you get a good idea of what the test is going to be about? Okay. And I don't like trick you by saying, hey, this is the test, and then you get something totally different. I won't do this. This is what the test is. And practice. So the best thing you can do is do practice problems of each type. So there's a lot of ways of doing practice problems. One is going back and looking again at the discussion posts. Okay, I did a practice problem in hypothesis testing on the discussion forum. Okay, where I did one that is done right. I'm not going to do it wrong just to trick you or anything. I did a practice confidence interval question, right? And look at those. Those are nice models for what the answer is going to be like. There's a lot of writing on this test. The other thing you can do, but you have to do it right, that is to go back to your assignments, those questions that you had. But you want to really be careful about the way you do them. Don't just answer the questions. What you want to do is you want to read the paragraph and then see if you can answer all of these questions in hypothesis testing or in confidence intervals before you even look at the possible answers. Does that make sense? Because I'm not going to give you a multiple choice thing or that type of thing. You know, the computer's not smart enough to read what you wrote and decide if you wrote it right. So the computer gives you all the choices and you choose which is right. See if you can write those out before you even look at what the computer said. And I recommend doing that as you're doing all of the assignments, actually, from now on, is try to do the writing before you look at the choices the computer gives you. Does that make sense?
So, for example, like I had a question on and I took a picture of my work.
Mm-hmm.
Was that actually better for you to see where we did the error?
Yeah, actually, then I can tell you where it was. Otherwise, I just see your number, right?
Right. Well, yeah.
I could sometimes guess from the number, but sometimes it's hard to guess.
Okay.
Oh, by the way, one of the issues that have been happening is round-off issues. That's not a problem on this test because I'm grading it.
Okay.
A computer grading it. You know what I mean? So I don't take off points if you have a round-off issue. If you've shown all your work and all you did is round, 3.97 to 3.
Well, remember that gave me a totally different answer. It was like 2
Right,
points.
totally different. That's a whole different thing.
Yeah, but it was because I rounded the first part of it, and you said don't round until the end.
Right. And that will give you a totally different answer. But here's the thing. When you take the test, the midterm, it's not a computer grading it. You show all your work, and you're going to get full credit, even if the rounding was totally different. Does that make sense?
Okay.
But if you don't show your work, even if you get the right answer, you're not going to get credit.
Okay.
So that's a big difference between the computer assignments and your midterm. The midterm is all about the work shown. So it's how many pieces of the statistical understanding you had. That's what I look at. Not was the number right at the end. Do you see the difference?
Mm-hmm.
Computers aren't smart enough, or maybe I'm not a good enough programmer, to be able to read through, paragraphs of work and figure out if you understood it. Okay? But people are smart enough to do that. Does that make sense? So definitely show your work, lots of writing. If you leave anything blank, that means I can't give you partial credit. And then I cry. And then you cry when you find out you got a bad score. So don't make us both cry. So show lots of work, and then I can find credit for you. Does that make sense?
Yes.
Okay. Any other questions about this before I move on to the next piece? We don't have too much more. I want to spend time on this because this really tells you what the midterm is going to be. The rest is just some things that you can do for studying. Okay, so let me hit the back button, I think is best. Okay, so in week 8, I did a little practice exam. This is kind of a practice exam I give for all my classes, so it's not all exactly like the sketch, but there's some things you can do. So for example, for the true falses, if you clicked on that, don't choose all of these because you don't even know what a nova is. That's going to come up in a few weeks. Don't choose this chi-squared. You don't know what it is. Don't choose regression analysis, but you can choose the other 4. Hit submit, and it'll give you true-false questions. Hundreds and hundreds of them I put in here. Okay. It also gives you, like, if 15 cards are selected out of a 52-card deck, then the distribution of the number of hearts selected follows binomial distribution. What do you think? True or false? The worst thing you can do is leave it blank, so choose something. And I'll go with the majority and see what happens. Okay, so you're saying true, so click it. No. Okay, the events are not independent, since if a heart is selected, the probability of selecting a second heart goes down. Remember, with binomial, you have to have the probabilities the same. If you get it, if you get the heart 13 times in a row, then the chance is 0 you're going to get another heart. Does that make sense? So, by the way, these little sad faces with the XIs, those are bad. Okay, so make sure, don't just look at the sad face, also read what it says, because it'll tell you why it's true or false. And even if you get it right, then do that. I'm not going to do hundreds of these. I'm going to let you do them. How many do you think you should do? I don't know. Most of you probably have more things to do with your life. I recommend doing them until you start getting them all right. If you get 5 in a row right, you're probably good. But if you keep getting them wrong, I keep going. Does that make sense? Because there are hundreds of these. Okay, so that is one little piece. Again, this, let's see, it was here and here. Okay, and then there's questions here. And these are, again, some of these, the first there aren't 19 questions on your regular exam. I put a lot of questions here. And they're slightly different, but there's also a key to this. Okay, if we go back. There we are. I don't even remember what I put in this. Ideas of studying for the test. Ah, yeah, I saw this. So you can rewatch the videos might help because those are worked out examples with the full thing. Okay, with the full sentences on the past chapters, of course. Read the chapters. It should say 1 through 9. Sorry about that. I think when I wrote this, it was chapters up to 10, and we only go to chapter 9. So I apologize for that. And you could do the problems from the chapters, the ones that have not necessarily odd, but the ones that say show solutions in the book. Take the practice test we just talked about, look at the structure, and then relax and study. Okay, any questions at all about these ideas? And of course, you can go back and rework out the homework problems too if you want. Just a note, it doesn't cover chapter 10. So I recommend starting chapter 10 a little bit later than usual because you really want to focus on this test. But then, right after the test, get to chapter 10. Next week's webinar, I'm probably going to do a little later than usual. I've been doing them all Mondays and Tuesdays. I don't know if you've noticed that. But I think I want to let you take your test first, and then I'll do a webinar on the new stuff to think about. which is chapter 10, and then I'll talk more about the project. So I'll probably make the webinar like maybe Wednesday or Thursday. If there's any requests, then I'll take those in mind. But I'll probably make it a little later because I want you to focus on the test. So I think I'm going to call it an evening for me talking about anything new or planned. And as always, though, I will happy to answer any of your questions. We still have, some of you are still here, Linda and Claudia and Stephanie and Sean. I know a few of you had to leave a little early. But if there's any questions, as always, I'll hang out. Yeah?
I just have did you see my post in regards to not be able to see Morgan still? Is that a Canvas issue? Should I contact anyone because I can't see it?
You're not able to see what?
You know how you said make sure that you answer a post that it hasn't been answered to?
Right. I read that. Did you see what I put on your comments?
Yes, but
Okay,
it's
I
still.
did that because I decided that was a personal thing, so I decided. Yeah, so I fixed that. So there shouldn't be a problem next time. And I gave you the 1 point that I took off of that, but the others were different.
Yeah, but I still can't see it.
You can't see Morgan's post?
Nope.
You can't see anybody's posts?
I can see everybody's post, but as far as I can tell, it's just Linda posted her post and I answered.
Yeah, something got stuck in between, and then it got changed. And that is actually what happened, but it got fixed.
Okay. So I don't have to contact anyone.
No, you're fine with that.
Okay.
That was a small issue. The bigger issue was understanding some of the...
Right. And I see I found what you wanted, so thank you.
Yeah.
Have a great night.
Okay, you two have a great night. And Stephanie and Linda, any thoughts?
Okay, good night. Thank
Good night. Okay, for all of you watching as an archive video, thanks for watching. Next week we'll probably have a later one, but make sure you get to me quickly about where you're taking that midterm. If you're taking an LTCC, make sure you get that appointment quick before someone else grabs that time. So until next week, I will see you, and good luck. I wish you all success on this midterm. I'm hoping that almost everyone, or hoping everybody, gets a really good grade. So I will see you next week, and I'll be happy to work with you if you have any Q&A questions. Post on them, please.